Let's talk about related rates in this video. So there are six things I want you to keep in mind when you're solving a related rate problem. So the first thing is understand the problem. In particular, identify the variable whose rate of change you seek and the variable or variables whose rate of change you already know or variables that you're already given. And number two, develop a mathematical model of the problem. You could draw a picture and label the parts that are important to the problem. However, be sure to distinguish constant quantities from variables that change over time. Only constant quantities can be assigned numerical values at the start. Thirdly, write an equation relating the variable whose rate of change you seek with the variable or variables whose rate of change you know. The formula is often geometric, but it could come from a scientific application. Fourthly, differentiate both sides of the equation implicitly with respect to time. T. Be sure to follow all differentiable rules. The chain rule will be especially critical, as you will be differentiating with respect to the parameter of t. Number five, substitute variables for any quantities that depend on time. Notice that it is only safe to do this after the differentiable steps. Substituting too soon freezes the picture and makes changeable variables behave like constants with zero derivatives. And lastly, interpret the solution. Translate your mathematical results into the problem setting with obviously appropriate units and decide whether the results make sense. For instance, if your person is running, they should not be running at a crazy speed such as 500 miles per hour. That is not
Okay,
humanly
with this first
possible. And
example,
it says, assume that the radius of a sphere is a differentiable function of t and let v be the volume of the sphere. Find an equation that relates dv over dt and dr over dt. So this is a pretty straightforward, simple question. What it's requiring us to already know is the equation for the volume of a sphere, which I highly recommend that you memorize these and prioritize these into your studying because knowing the equations of the area and volume of your shapes or of your geometric figures can really help you out on test day and can save you a lot of time. So when you have a sphere, the volume of this equation is going to be v equals 4 over 3 times pi r cubed, right? And because we're trying to find equations that relates dv over dt and dr over dt, we just have to find the derivative of the volume. So here we have dv over dt, right? Because we apply power rule and respect to time, and we do the derivative with respect to time. We'll have this with the left side. Now we move on to the right side. We can rewrite this as 4 pi r cubed over 3. So now just looking at the numerator, you can easily just apply power rule. So let's apply power rule. So we have 4 pi 3r, and then 3 minus 1 is going to be 2 over 3 with respect to time. So we'll have to multiply it by dr over dt, right? Although this is correct, we can further simplify this by having dv, let me write that a bit bigger, over dv over dt equals, so we have 3 times 4, which is going to be 12 pi r squared over 3 times dr over dt, which the right side can be simplified by just dividing that out into 4 pi r squared times dr over dt. And this shows us that we do have a differentiable equation that relates both to dv over dt and dr over dt, because we have dv over dt on the left side and dr over dt on the right side. And that's the derivative of the equation of the volume of a sphere. So let's move on to another example. Okay, with this example, it's a bit much of a tougher problem, but we'll get through this. So it states a hot air balloon rising straight up from a level field is tracked by a rangefinder 500 feet from the liftoff point. At the moment the rangefinder's elevation angle is pi over 4, the angle is increasing at a rate of 0.14 radians per minute. How fast is the balloon rising at the moment? So I drew the balloon, and we know that this is going to be a right angle, right, because it's perpendicular, okay? And we'll write RF for the ranger, RF for rangefinder. Okay, and then we know that it is 500 feet away. And this is our angle of elevation, but we don't know what it is, so we'll just write it as theta. And we know this is the height, because we're trying to find how fast is the balloon rising at that moment, right? So we can carefully identify. So let h be the height of the balloon and elevation. So we're trying to find dh over dt, right? We're trying to find how fast. So we're trying to find the rate of which the balloon is rising at this moment, at that moment. And we know that d pi, so that the d theta over dt equals 0.14 radian per minute. Now that we have this set up, we need a formula that relates both h and theta. So we know that we have theta, we have an angle, we have the opposite, and we have adjacent. So therefore, we can use tangent. So we know that we can use tangent of theta is equal to the height or the opposite over the adjacent over 500. So now we can do the differentiable explicitly. We can find a derivative with respect to time. What I do want to do to make this much easier is we want to solve for h, right? Or more specifically, we want to do the differentiable of the height, right? The rate of the height increasing. So I want to isolate h. So to do that, I want to multiply each side by 500. So we have 500 times tangent of theta equals h. And now we can do the implicit derivative. So we can do d over dt on this side and d over dt, right? And then we know that when we apply the derivative of this, or when we apply the derivative of tangent, it's just going to be secant. So we have 500 secant squared of theta, right? And then we do the derivative of this with respect to time. So we have d theta over dt is equal to the derivative of h with respect to time, which is going to be dh over dt, right? So let d theta over dt equals 0.14 radians per minute. So we can substitute this for that. So we have 500 secant squared of theta times 0.14 is equal to dh over dt. Right, so it's the question stated at the moment the range finder's elevation angle is pi over 4. So we know that because the rangefinder elevation is equal to pi over 4, we can substitute that into this equation. So we have 500 of secant squared is pi over 4 times 0.14 is going to give you the rate at which the balloon is increasing, so dh over dt meter dt. If you were to input this into a calculator, right, you should get 140 equals dh over dt, and that is our answer. Okay, with this last problem, I wanted to deal with a 3D dimensional figure. So the problem states a water tank has the shape of an inverted circular cone with base radius 2 meters and height of 4 meters. So let's already draw what we are given. So we're given that the radius, right, so from here to here is 2 meters, right? Is 2 meters. And we're given that the height of this cone, right, so we're from here is 4 meters. Okay, let's keep reading. If water is being pumped into the tank at a rate of 2 meters cubed per minute, find the rate at which the water level is rising when the water is 3 meters deep. So we're given the rate at which the volume is increasing, or the amount of water that's being pumped into the tank. So we can write this as dV over dt. You know this as 2 meters, oops, we know this as 2 meters cubed per minute, right? And we're trying to find the height at which it's rising, right? So this is dH over dt. Mhm, mhm, right? We're trying to find the rate at which it is rising. So we're trying to find an equation that will relate both an equation that would relate. We're trying to find an equation that relates both dv over dt and dh over dt. So from this shape, we know that, or we can note that 4m is half of 2m, right? So we know that 1 over 2 h, right? The height is equal to 2, or sorry, is equal to the radius, right? So we can apply this to this equation that will relate both dv over dt and dh over dt, which the equation that will be the volume of a circular cone, which is volume equals 1 over 3 pi r squared times height, right? You can look up where this equation comes from or how you get this equation, but basically circle times the height, which is like a cylinder, and the cone is 1/3 of a cone, and that's how you get a circular cone, right? It's 1/3 of a cylinder, and right, right. Okay, so then we can plug in this, right? Because we know from this relation 4 and 2, we know that 4 is half of 2, and therefore that this 3D shape height will always be half, or can always equal, or from this 3D shape, we know that the radius will always be half of the height, always. Right? Even if we look here, or if we look here, the same rule will apply. We know that the radius will have to be half of the height. Okay, so therefore we can plug this in. V over is equal to 1 over 3 pi over 1 over 2 h squared times height. And we can simplify this, right, by 1 over 3 pi. Then we know that this is going to be h squared over 4 times h. We can also continue further simplifying this by 1 over 3 pi over times pi cubed over 4, right? Okay, and now we want to do the implicit derivative with respect to time. So we do dv over dt equals 1 over 3 pi, and since this is cubed, right, we can do 3h squared over 4 times dh over dt. So now that we have an equation that relates both dv over dt and the h over dt, right, we can start plugging in what we already know. So we know that the rate at the volume is being filled is going to be 2, right? 2 equals 1 over 3 pi 3. And we have to remember to the question. It says, find the rate at which the water level is rising when the water is 3 meters deep. So the height, we're not looking at the height of 4. Rather, we're looking at the height of 3, right? We're looking at 3 meters now. So the height is 3 meters, right? And squared over 4 times dh over dt. And we're trying to solve for dh over dt. So we can move everything to one side by dividing the right side by itself. So we can do this 3 over 3 squared over 4. And also divide that by here, right? We're going to divide that. So we have 2 over pi over 3 times 3 over 9 over 4 is equal to dh over dt. Now that we have this, we can further simplify this result by multiplying things out. So we have 2 over pi over 3, 27 over 4. And we can continue to simplify this out by, so we can just multiply, so 27 pi over 12, right? And then we can rewrite this as 2 times 12 over 27 pi. And then 2 times 12 is 24 over 27 pi. And we can simplify this even further by 8 over 9 pi. And that should be the rate. That should be the rate at which the water level is rising when the water is 3 meters deep. So this is our answer.